K-means clustering. K-means clustering is a very common unsupervised learning technique with a very wide range of applications. It is powerful because it is conceptually relatively simple, scales to very large datasets, and tends to work quite well in practice. In the following section, you will learn the conceptual foundations of K-means clustering, how to apply K-means clustering to data, and how to deal with high-dimensional data, that is, data with many different variables, in the context of clustering. K-means clustering is an algorithm that tries to find the best way of grouping data points into K different groups, where K is a parameter given to the algorithm. That is where the K part of the name comes from. So the algorithm begins by randomly selecting K centroids, and the centroids are updated to be the mean of all of the data points assigned to them. And then step 2 is repeated until no data points change which centroid they are assigned to after the centroid is updated. Let's go ahead and do an exercise together. K-means clustering on income age data. In this exercise, you will first standardize the age and income data from the aging.csv dataset provided within the lesson 3 folder that we downloaded. So for that, I'm navigating to lesson 3 folder and opening a Python console. First thing to do is importing pandas. Now let's load the aging.csv dataset present within the lesson 03 folder. Now we're going to create the standardized value columns for the income and age values and store them in zincome and zage variables using the following code. I'm going to copy paste it here to make it a little bit faster. Instead of income, we're going to use the age. Now we're going to use the matplotlib to plot the data to get a sense of what it looks like. For this, we're going to need the first importing the pyplot. To make sure the plot shows up in the Jupyter notebook, we will tell the notebook to allow matplotlib to plot inline. Please note that this only has to be done once per notebook where we are plotting. Finally, we will use the scatter plot to plot the data. Okay, and we can also label the axis as income and age. So we need to be writing all in the same cell. Here we are. Alright, now the exciting part came. We will be using sklearn package, and this is a package that has numerous machine learning algorithms, and we will use this to perform K-means clustering using the standardized variables. I'm going to copy paste a code here to make things a little bit faster, but of course you can find this code in your exercise 12 file that you have in your lesson 03 folder. Alright, everything looks good. Now let me explain you what I did here. First, I imported the cluster module from the sklearn package, and then I defined the model to be a K-means algorithm with specific parameters, 4 clusters, and the random state just ensures that everyone gets the same answer since the K-means algorithm is not deterministic. The final line fits the model to our data. We specifically only fit it to our zincome and zage columns since we don't want to use unstandardized variables for clustering, right? And now next, we will create a column called cluster that contains the label of the cluster each data point belongs to, and use the head function to inspect the first few rows. Here is how to do that. Alright, this is the output you should get. Now I'm going to copy paste a code here and talk about that code, and of course you can find this again in your exercise 12 file. We're in the final step here, and we're going to be plotting the data points, colors and shapes coded by which cluster they belong to. We're using the unstandardized data to do the plotting so the variables are easier to interpret since we already obtained the clustering from the standardized scores. This is just for visualization purposes and the absolute value of the variables is not important actually. And we define the markers and colors we want to use for each cluster and then used a loop to plot the data points in each cluster separately with their respective color and shape. We then changed the labels of the axis and displayed the figure. So here is what you should get. Well, congratulations, you have already successfully performed k-means clustering using the scikit-learn package. In this exercise, we dealt with a dataset that had only 2 dimensions. And in the next section, we will take a look at how to deal with datasets containing more dimensions. Things are getting more and more interesting for us. And in the last exercise, we created our first machine learning model, and I hope it was exciting enough for you. Now let's have a look at the high-dimensional data. When we have additional dimensions, it becomes difficult to visualize our data. And dimensionality reduction techniques are commonly used for this. The idea of dimensionality reduction is to reduce multidimensional data to 2 dimensions for visualization purposes while trying to preserve the distance between points. We will use principal component analysis, PCA, for this. So let's do another exercise and see what we're talking about here, dealing with high-dimensional data. Now, in this exercise, we will deal with a dataset 3_call.csv that has 3 columns, and we will standardize the data and perform k-means clustering in a way that will scale the data with many columns. And to visualize the data, we will perform dimensionality reduction using PCA. Now, first thing to do is again importing pandas. Now we're going to read in the 3_call.csv dataset present within the lesson 3 folder and inspect the columns. Now I'm going to copy paste a code here and then talk about it. Alright, what we do here is standardizing the 3 columns and saving the names of the standardized columns in a list that calls. So we used a loop to standardize all of the columns instead of doing them one at a time. Now let's inspect the new columns using the add function. Alright, now it's time to perform the k-means clustering. Again, let me put this here. And we performed k-means clustering on the standardized scores. For this, we first needed to import the cluster model from the sklearn package and then define a k-means clustering object, which is model, with the random state set to 10 and using 4 clusters. Finally, we also used the fitPredict function to fit our k-means model to the standardized columns in our dataset. Now, let's keep going here. And let me explain you what happens here. We performed a PCA on our data, and for this we needed to first import the composition module from sklearn and define a PCA object with n components and set to 2. We used this PCA object to transform the standardized data and store the transformed dimensions in PC1 and PC2. Okay, right, now let's keep going. What we did here was plotting the clusters in the reduced dimensionality space using the loop to plot each cluster with its own shape and color. Note that the x and y axis here are principal components and therefore are not easily interpretable. However, by visualizing the clusters, we can get a sense of how good the clusters are based on how much they overlap. And next, we just wanted to quickly investigate what each cluster seems to be capturing. We can look at the means of each of the variables in each cluster. Please note that this is just one example of how to investigate the different clusters. You can look at the first few examples of data points in each to get a sense of the differences. In more complex cases, using various visualization techniques to probe more deeply into the different clusters may be useful. Now, congratulations! You have successfully used PCA for dimensionality reduction. You can see that each cluster has different characteristics. Cluster 0 represents customers with high incomes, low ages, and relatively fewer days since the last purchase. And cluster 1 represents low income, low age, and more days since the last purchase. Cluster 2 represents low income, high age, and fewer days since last purchase, and cluster 3 has high income, high age, and more days since last purchase. I hope you enjoyed this exercise.